This is lecture 4, and these two lectures are going to be going to be very interesting. This lecture is going to cover all about functions, and let's get into the details of it. So, how do you define a function? Let's go over the basics again. You can define a function. You must need to do the following. You need the function definition. You need the function prototype, which is at the head, correct? And then you want to call it. Also, you can and should use a standard library header file to provide a prototype, right? If it exists before. So in this case, you have this function simple, define. Here's the prototype, here's the definition, and somewhere here do you make the function call. Okay, so we know the definition of a function. So typically, a typical function return value. Okay, you make the function call and it returns something back. Okay, that's fine. All that is good. So far, so good. Why need prototypes? That's the interface for the compiler. The compiler knows, what to expect from this function. What does the function take in as argument, and what does it return? And it's okay to drop the variable names in the prototype. You can do dot 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 when there are variable number of arguments, and it's typically, for example, things like printf, which has a variable number of arguments. Okay. So all this is good. Okay. So function arguments are always passed by value, except in just one case, and we'll look at that, passed by reference. So here's what's happening when you pass in a double. That copy of that value x is put into the stack and the function gets invoked. Okay, so that's kind of what happens here. Maybe there are multiple arguments here. The same thing happens. Another 2 argument function. Sure, all that is good. Okay, here's the interesting thing. About arrays. Things are all array is not really an ARR is not. In this case, it's not really an array, it's actually a pointer. Although it looks like an array, it is actually a pointer. You can write the rest of the function, treat it just as it would be an array, but it is really a pointer. Okay, you cannot, what that means is if you do size of this, you'll just get size of the first element. That is why you need n, which is the total number of elements in this array, or in this the array pointed by this pointer ARR. And how to enable array accessing. Okay, there are few exceptions. Okay, so here's the deal, right? First, an array declaration using the array name to label the storage. Second, applying size of to the array yields the size of the whole array. Yes, we spoke about that. And applying the address operator ampersand to the array returns the address of the whole array, correct? It means that 32 address of cookies, where cookies is the array, would return the 32-byte block of memory if int is 4 bytes, right? Because it has probably 8 is where it's defined that it has 8. It's of size 8. Yes, it's of size 8, right? As you can see here, this is of size 8. ARR size is 8. Makes sense? Okay. And remember the notations that int star are not synonymous in any other context except in function headers, right? You cannot do this to declare a pointer to the body of the you just can't do that. And what are the implications? Well, these passes and value, that is assign a new variable, but that value is a single address, not the contents of the array. This is important. It's the single address, not the contents of the array. Now let's look at this with const. I think we have already looked at this. When you have const, it means that none of the contents can't be modified. That's what const at the start mean. And if you put this after the asterisk, what that means, if you do double star const AR, it means that you can't modify the what it's pointing to. It really doesn't matter, because even if you modify here, this is not the right thing. But anyways, we'll see where this is applicable, where it makes sense. So just to make sure, yeah, modifying the array. If you want to modify, you want to remove the const, right? Just take it's show array, so you can put the const safely, because you can't do that. And what that means is something like this will fail if you try to do that for a const array. Okay, pointers and consts. So just, I think we have already spoken about this. We can do this, but this is, there's a nice picture here. Okay, so first is, okay, what does this mean? Pointers to constant and constant pointers. This is a pointer to a constant integer. You can change the address, but you can't change the value. Correct? You can change the address. It can point to a different variable now. And in this case, if it is an int star const the pointer, it means that it points to a specific address. That is, so you can't do this, but you can change the value. And I think here's the interesting thing. Here's the other thing that you should think about, that you should always use const when you can, because if you don't use constant and there is a constant int, let's say this is a constant array, and your function definition sum is not a constant, then you can't pass this months to this sum, so it's not allowed. Hence, you always, if you want, always try to use constants when you can, because it definitely protects you from programming errors, and it also allows you to allows both const and non-const parameters to be put in it, to be kind of given to your function. And now we spoke about two-dimensional arrays, so let's look at them again. In this case, let's say this is an array of 3 by 4, and what is the prototype? And you want to do some data. What does this prototype look? The prototype looks something like this. It means AR2 is a pointer to a array of 4 records. Okay, array of 4. So that's the idea. It goes through these 4, then these 4, and these 4, and how many times does it have to go through? The number of rows, which is specified here. So size is the number of rows. Instead of this, which is a little bit hard and tricky to read, you can always do something like that, which makes it easier. And I would definitely recommend this over this. Okay, C shell, I think we all know that. Okay, so this is something interesting. Here, as you can see, you're newing up some memory. Okay, you're doing some build string, but the interesting thing is you're newing up some memory. So, and that's what it's getting returned. So you need to then delete it. It's the responsibility of the outside function to make sure that you delete this pointer. And since this is a pointer variable, you need to do delete brackets PS. Otherwise, we'll just end up deleting just the first character, which is not what you really wanted to do. And once again, structures you can pass by value or by reference. And we'll look at passing by reference examples very soon. That's where we we understand what it means to pass by address. Okay, so here's the interesting thing. If you want to pass something as an so this is, we know about this, right? So you can always do this asterisk and then pass the address of the structure. In this case, only the structure doesn't get copied completely. So we know about that. But I think it's in the second page. Okay, maybe not. Okay. Array objects. Okay, so once again, we know this. Don't forget the ampersand. Recursion. Okay, we know about function recursion. We are going to skip that. Okay, so I think the reference part is probably going to be covered in the next chapter. That's where we'll see it. Function pointers. So the idea here is it's a delegate. So if people who are familiar with C#, it's a delegate. So let's say you have a function f and you want it to execute a function bar. In that case, what you can do is you can pass the address of bar to f, and then f will just invoke that function. And that's what it does. If you pass think, it means you're passing the address of this function, and then process can then invoke thing. Obviously, if you're calling thing here, what it means is you're invoking thing, and the return of the thing passes to thought. And how do you define a prototype? Let's say if this is a prototype, how do you define the function definition? Once again, it's important to associate it within brackets, otherwise it will say, okay, it's a double, otherwise it will be tricky. Otherwise we get associated with the int and with the double star and not the pointer. So what you want to do is that pf is a pointer to a function that takes in an int and returns a double. Okay, this is important. And so this is the difference. Is a function, if you just do this, and what it will mean is pf star is a function that returns a pointer to double, right? Because it will think that this is a function definition, and that's not what you want. Okay, so it will say, oh, it's a function that returns a pointer to double. No, you don't want that. You want to say that this is a pointer to a function. It's not a function itself. And the right thing, okay, and we'll talk about auto, and I think you should definitely use auto. Here's the interesting thing. Given a function pf that takes in an int and points to double, the right way to call it would be to do pointer pf and pass in phi. But you can also do something like this. So you can completely escape the star asterisk pointer. Well, it's not really right, because the right thing to do from what we have all learned is this, but it does allow you to do that. Okay, so yeah, that's what happens. Variations, once again, you can use array, you can skip the name, you can do star. It basically is the same thing. Okay, this is the neat thing, right? So given a function f2, just do auto. If you do auto, then the compiler will figure out what the type for p2 using f2's definition, or prototype definition, prototype declaration. So that's what you would like to do ideally. So given from going forward, try to use auto. That's the idea. But you should know what's happening underneath. Okay, so it's appreciating auto. Yeah. Okay, there is one drawback. You can do something like this instead of PA, and the compiler will just work fine. What it means is that if PA was an pointer to PA was a pointer to the function, then you want to use the address of PA, not point to PA directly, because that would make no sense. But then the compiler will still allow you to do that in case of auto, but then later on some more time it will crib when you try to use it. And type def, we know about that as well, and that's all about functions. Now let's finish functions with this last chapter. Now the different kinds of functions, let's go over them inline. So what is the idea here? So this is what is happening when you are invoking a function. So let's look at that. That when you invoke a function, I thought there was a nice stack, but I don't seem to find it now. But what's happening, this is what's happening. The program stores the memory address of the instruction immediately following the function call, copies the function arguments to a stack, jumps to the memory location that marks the beginning of the function, executes the function code, and then jumps back to the instruction whose address is saved. Jumping back and forth and keeping track where to jump means there is some overhead in elapsed times to using functions. What you can instead do is have an inline function. What that means is if the execution time is too short, then the inline call can save a large portion of the time used by the non-inline call. So you will if the overhead is not worth it, that's kind of the idea here. And what you can do is you just preface the function definition by keyword inline, and it does not have to honor your request. It will still do the right thing, so as to speak. Now you should ask the question that why shouldn't all your functions be inline? And you should think about that, like, is that a good idea or a bad idea? Why having all very large functions in line that are used multiple places may not be a very good idea itself. Okay, so it doesn't have to jump. Selective. Here's the idea. If the code, then the inline function. On the other hand, if you're not saving a large portion, if you're not, then the absolute time savings may not be great unless the function is called frequently. That's the idea, right? Because you're bloating your executable size. So that's definitely the case here. Okay, and this is macros is what you would use in C. You don't want to do that going forward. Okay, reference variable. This is important. Now, think of reference as an alias. It means when you say int address rodents is equal to rats, it means that rodents is a reference to rats. Now, let's look at this. This is actually very interesting. What it means here is that when you do this, address of rodents, it's actually the same. Rats is this, rodents is the rat's address and the rodent's address are the same value. They are not two different things. Just think of it as another alias. That's how I think of it in my mind. It's another alias. It's the same thing. It's the same address. It's the same value. It's just an alias. Okay, and yeah, you can't do that. You cannot do that. You should initialize a reference variable when you declare it. This is important. Here's another interesting thing to see. Now let's say rodents is bunnies. Okay, so rodents, you initialize something. Now you make and then there was these rats and rodents were two things. They were the same. Now there you created another integer variable bunnies is equal to 50, and then you made rodents to point to bunnies. Okay, now what happens? Now let's say you're now trying to print these things. What happens here? We think that the program apparently attempts to make rodents reference to bunnies, but what has actually happened is that all three now point to bunnies. Even the rats changes to bunnies. So it's not that just the rodents change to bunnies, because as we know that rodents was just an alias to rats, correct? Yes, that's the important thing. Okay, and this is neat. Reference as function parameters. So we can, this is where it is passing by reference makes sense. So instead of an asterisk, you are basically creating an alias and add address x, and you just pass in times to it, and then you are just using that. You can change whatever value you would need for that. So that's the interesting thing. So you use pointers or you can use reference. Okay. Okay, so the idea here is if you once again constant defines that you're not going to change the value of the reference, correct? And if you try to do that, then it will give you an error. Same idea, use constant when you can. We know that. Pre-throws. Okay, let's see this. Okay. Once again, here you're returning something which is also a reference, so that you are creating, you are taking in two, you are creating target and the source, and you're returning a reference to the updated value. In this case, you're changing target and you're returning it. So you're saying that, hey, this is a reference to that. That's the idea. If the return type would be declared of free throws, instead of the same return statement would return a copy of the target, hence the copy of the team. But the return type is a reference, so that it means the return value of the team is passed to accumulate. Okay. And you can do something like that. Since this is a reference, or it returns a reference, it means it returns a variable. You can assign that to something. You can if you want to. And there is a way, and you'll see that, okay, you want to stop people from doing that, because that will be ugly. And this is how you can do it. You can just make the constant, you can make the return type a constant, means that, hey, don't try doing that. Don't try assigning it to something else. Then this will fail. It will throw an exception. So this will fail. I don't see why we would ever not want to use constant there, but there may be some programs that it's needed. Okay, now what's the difference between between references, pointers, and things like that? So let's look at this one. Now here's where you should not do something like that. Now you're trying to return temp, which is an internal local variable, and you're trying to return that as a reference. This is very bad, because the moment this function execution finishes, the temp is no longer in scope. So it can be reclaimed. And now if you try to return it, somebody tries to use it, God knows what value is that are they going to get when they try to do that. So don't do it. Okay. Okay, now this is where I think you want to use references versus pointers. And the interesting thing is that inheritance. Okay, I think that's where it really shines. Class in the brief OS stream, so output stream is a base class, because output file stream is derived from it, and same is and what happens is that in this case, if you have a function that takes in an O output stream object. To it you can pass both a file or a cout. You can pass both of them and it will just continue to work fine. And you can, this magic can be done when you are using a reference. So this is where I think it really shines. And that's the idea. The two main reasons for using reference: to allow alter, sure, we know that; to speed up, yeah, sure, is important, such as large, yeah, this makes sense because use a pointer. So when do you use a reference? Following are some guidelines. Okay, when do you use a pointer? When do you use pass by value? When do you use a reference? So these guidelines are important. Let's just go over them. A function should be passed. Users pass data without modifying it. If a function uses pass data without modifying it, if it is small, pass it by value. If it is an array, make it constant. Use a pointer because that's the only choice. There is no reference usage in array. So if it is an array, you have to use a pointer. And it's a good structure. You can use a const pointer or const reference. It really depends. You can save the time and space. Yeah. If it is an object, class object, use a const reference, okay, not a pointer. The semantics of the Y, once again we spoke about that before, sorry. The semantics of the class design often require using a reference, which is the main reason why C++ added this feature. And now if it is, once again, so I hope you get the idea here. Default arguments, you can do something like this here. If you have a big function, आ जाने बोलो ना लो ना, 5 मिनट रुकोगी क्या यार? Okay, for default arguments, the idea is that starting from left to right, you can give a particular parameter a default value, so that when you call left, you can just give the first pointer, the value to the first variable, first argument, and we're not worry about the next. As you can imagine, you have to do left to right. What it means is you can't skip a default here and then suddenly have a default for the second one. So that's the idea. Okay, so these are some things that are valid and what are not valid. Function overloading. Once again, now this is again, I think we are very well versed with it. Is that the same name can take different types of input. It can take an int, long, etc., and see the compiler will decide the one that matches best. And in case if there is a there is any ambiguity, then you will fail. Okay, so we'll give some example. Yeah. So yeah, for example, if you do this year, year is an unsigned int, so it doesn't know which one to use, and then it will give an error because it doesn't really know what to do. So you have to be careful with that. Okay, sometimes signatures are different, but nonetheless can't exist. Obviously, this can't exist. As you can imagine, they're the same thing. Okay, not okay. This is overloaded. Character and const character. Function does discriminate between constant and non-constant value, but it does not differentiate between if you just have double character and okay, this is not overloaded. These are just two different functions. Okay, so once again, it's the signature, not the function type, that enables overloading. For example, you can't just change the output and then say, okay, these are two different overloads. The output, the return type doesn't really matter for overloading. When to use function overloading? By using a single function is simpler. There is a function to write instead of two. Memory requires more memory. If you decide to modify a function, you have to edit only one. Or if you require different types of argument, different arguments are of no avail. In this case, you should use function overloading. Once again, single function with default argument is simple. If you can do that, do it. Function templates. So we will look at class templates, but the idea for function templates are similar to that. And let's look at this. The syntax is important. Template, type name, some value t, and then you have the function that uses that type. And when you want to use this, you can just say, let's say you do this. Now you can say swap, xy guarantees void. The interesting thing here, as in the case of class, you're not really specifying swap int, something. It just kind of infers that. So that's the interesting thing here. So this is important. You don't see that in code, but the compiler generates and then uses it in the program. The second swap has two double arguments. Every time you do this, the compiler is going to generate this piece of code for you. That's what is happening underneath the covers. And you can have overloaded templates. Is it to write a template function that cannot handle certain types? Sure. Specialization overrides the regular template, not the non-template function. Yeah. So you can have specializations. What that means is that here is the non-template function prototype. This is the template function prototype, and this is an explicit function prototype for job type. Okay, so you say, hey, for job we have to do something different, right? Because for job you may not be equal to the maybe the assignment operator is not overloaded, so you may have to do something specific for that. So that's the idea here. And the specification overrides the regular template, and the non-template function overrides both. So this takes precedence over this and this, as you can imagine. The declare type facility is a bit more complex. The compiler has to go through a checklist. Okay, so yeah. So the declare type, you can, it's kind of creating a type at a runtime. That's what it basically means. And that's it. So I hope we quickly covered all about functions in this particular lecture. In the last lecture, we'll talk about classes. Thanks. Bye.
In the last lecture or in the next lecture?
Actually last. मैंने 5 lecture बना दिए.
So in the last